Hello folks, this is Dan Watson here with another video today. This is our 6th video in the new series. This video is going to be about additives. But before I get into the meat of this video, let me explain again why it makes any difference if you listen to me. Give you a little bit of background on me. I'm a certified lubrication specialist from the Society of Tribologists and Lubrication Engineers, otherwise known as the STLE. I'm an AMSOIL jobber. It means I have been associated with the AMSOIL Corporation for the last 32 years in the lubrication business. And prior to that, my background was in the Navy's nuclear engineering program. So those are my credentials, so to speak. And as always, I will ask you, and not bashful about asking you, that if you need anything in the way of products from AMSOIL, or if you're just looking for advice on any lubricant that you're considering buying, then contact me. Contact me right through this video. You'll see that you can go to thelubepage.com and you can contact me there, or you can contact me directly to Dan Watson at thelubepage.com, or you can call me at 800-370-2986. Now, let's get on with today's video. I'm going to talk about additives. Now, I want to make sure you're not confused when I talk about additives. Some people immediately think of things like greased lightning, STP additives, things that you pour into what would otherwise be a pour oil to try to improve its performance capability up to where it should be to begin with. That's not the additives I'm talking about. Those are supplemental additives added to your lubricant after it has been manufactured. I am talking about the additives that have to go in the lubricant in order to have a finished product that matches up to the application that you're going to be using that oil or product for. Now, when we look at this, we have to have a definition, as always, to start out with. What is an additive? Okay, I'm going to read it for you because it's important to get it exactly right. It is a material that imparts a new or desirable property not naturally occurring in the lubricant base stock. Okay? Second additional definition. An additive may also reinforce a desirable property that the base stock already possesses to some degree. So in other words, we are going to be putting things in the base stock that's going to change the performance of the base stock. And I think you can catch on to that fairly quick, because I'm going to put different additives in a hydraulic oil and a gear oil and a motor oil so that they will match up with the expected performance of lubrication that is required for that application. So these additives, they tailor the oil to meet specific lubrication requirements. Okay, so how many of these additives are we talking about? Well, let me briefly run down through them and then we'll get into the meat of what each one does to some degree. My goal today is not to flesh these or drill down into these additives as deep as you can go, because there's just insufficient time and I don't want you to get tied up in this and decide you've had enough and quit because it goes too long. But we do need to know the additives and something generally about them. And then in later videos where we get into oil formulation and we start talking about the specific additives and where they go in the lubricant, then we'll drill down deeper into how each one of those additives is trying to accomplish that purpose. So we have two classifications of additives, those that are chemically active and those that are chemically inert. Okay, what does that mean? Well, chemically active means that some type of reaction will take place between the chemical constituents that we're talking about. Okay? And inert means that there will be no chemical reaction. There will be some other physical properties that are involved, but it will not be a chemical reaction which takes place when we use an inert additive. Okay? So one is active and one is inactive. Those are the two classifications. Now, in the chemically active additives, we have dispersants, detergents, anti-wear agents, oxygen inhibitors, rust inhibitors, and corrosion inhibitors. Those are all on the chemically active side. They're going to be doing something chemically to accomplish their purpose. On the chemically inert side, we have emulsifiers. Yeah, we'll define that shortly. Demulsifiers, pour point depressants, foam inhibitors, and viscosity index improvers. Okay, so we got two classifications, and those are basically where these additives fall. And all these additives in a combination, they're going to give us a finished product that's going to perform for us in a lubricating application such as motor oil, gear oil, transmission fluid, hydraulic oil, compressor oil, whatever it is. We will use a combination of these additives to get the performance that we want in those applications. So let's look at dispersants and detergents. They work together and they have quite similar activities. Dispersants will be working against certain byproducts of combustion that they will actually nullify, some oxidizers and some other chemical byproducts of internal combustion. Now, detergents, on the other hand, they're going to neutralize acids, and they actually work to clean the surface of the metal or the moving parts inside the engine. And the detergents and the dispersants in combination are required to keep these particulates in solution, not allowing them to plate out inside the engine. We don't want a whole buildup of these particulate things in places like small oil galleries or other places that they could cause an impediment to oil flow and create a problem of lubrication. Now, when they keep these guys in solution, one thing that happens is over a period of time, the chemistry that's involved, small individual particulates will come together and they'll form a larger little tiny droplet, if you will, and then the filter can take it out. See, a filter can only go down so far in its micron rating, and these things are formed at well below a tenth of a micron in size. But then these chemicals that we put in allow for these things to coagulate, form larger droplets, big enough for the filter to take out. So that's the purpose of dispersants and detergents. Anti-wear agents, that the name gives it away. These are additives that are designed to prevent wear. Wear takes place when the two surfaces, the metallic surfaces, typically cannot be separated by the oil film for one or more particular reason. And now I have to rely upon something to prevent iron, steel to steel contact. I'll use some type of sacrificial material on the surface, such as zinc, calcium, sulfur, phosphorus. One of these things will be in there, or a combination of those additives in order to prevent wear. So anti-wear additives are really all about preventing wear in the engine. So I go to rust inhibitors and corrosion inhibitors. Why do I even list rust and then list corrosion? Well, rust is a particular type of oxidation. There are other corrosion activities that take place which are more or less based on acid formation that is done through the byproducts of combustion. So rust is straight out going to come from oxidation, but other corrosion can happen if I have untethered acids that are allowed to get to the surface of the metal. So my rust inhibitors and corrosion inhibitors. Now that finishes the chemically active ones. We go to the chemically inert, we have emulsifiers and demulsifiers. Emulsifiers allow oil and water to mix better. Demulsifiers get the water out of the oil, okay? I'll tell you more on that in a minute. Pour point depressants, that of course is designed to make sure that the oil can pour out at colder temperatures. Foam inhibitors, oil that's full of foam cannot lubricate. Can't form a film because it's got so much foam in it that it can't keep the metal surfaces separated because it's full of air and foam. So we have to do with that. And then viscosity index improvers, we talked about that in the viscosity video previously, so I won't go into great detail, but they're there in order to give us multi-grade oils. Now let's get down and we'll do a little more quick on these with what they do. Okay, dispersants we already talked about. They're used to suspend insoluble oil particulates in the oil, and the detergents, they work with that, but they also, you could say, scrub the surfaces and prevent the attachment of acids and different things to the surfaces, so they keep a clean surface. Anti-wear agents, now real quick on anti-wear, it's easy to understand. The surface of metal is not in fact totally smooth. It has these things called asperities, and those are little peaks. If you saw it in a microscope, you'd think you had little mountain ranges running across there with valleys. And the problem is that when the two metal surfaces get close enough together, they start hitting those tips and knocking them off, and they create wear particles that go into the oil as they polish off that. So the anti-wear additives, they fill it in, they put an attached, lightly attached, by the way, for the on the surface, so that you don't get metal-to-metal contact. Okay. There are extreme pressure additives. We'll talk about that when we get into gear lubes at a later time, but they are much more tenacious and chemically attracted and attached to the surface of the metal. Oxidation inhibitors are just that. They are designed to prevent, where at all possible, prevent oxygen from doing its thing. Oxygen will react with anything. It's a -2 polarity, and it will try to get in and form these oxidized agents. And if you get the oxidized agents, then they will interfere with the actual molecular structure of our hydrocarbon base, and we can have things like varnish and sludge as a product of oxidation. So we put chemical inhibitors in to prevent the oxygen from being able to fill what they call polarity sites that would be in the base stock. Okay. And those are a variety of different chemicals can accomplish it. Different people use different chemicals, but that's the whole idea, prevent oxidation. All right, and then our rust and corrosion inhibitors come in two types. Acid neutralization, that's to prevent corrosion, and then we also have protective films, which prevent any of the acids or the oxygen from getting to the surface of the metal and reacting to the surface of the metal, creating rust. Okay. Emulsifiers and demulsifiers, we don't go in that too deep. Just remember, emulsifiers are used when we're going to be talking about metal working, where they want oil and water mixed together that they can run through the lathes to prevent chipping and breaking the lathe bits. Okay, demulsifiers are important, especially in hydraulic oils, because they allow for the water to be quickly expunged out of the oil, so that we don't have water and oil in a mixture. Imagine that in a hydraulic system under heavy pressure. The temperature goes up and the water flashes to steam. Messes up everything. It's called surging. Okay. Pour point depressants, well, those are very important for conventional oil-based stocks, because the waxes that are left in the oil will crystallize at very cold temperatures. So you put a chemical in which prevents the crystallization of the wax, keeping it in liquid form, therefore allowing the oil to go down to colder temperatures. And the pour point happens to be defined as the coldest temperature at which you can pour the liquid out of the beaker. Okay, foam inhibitors are just that. And how do we do it? We do it by, you're always going to get agitation that forms foam, but what you want it to do is collapse as quick as possible. So you put agents, chemical agents in that cause the bubbles of the foaming to collapse. And so the quicker we can collapse them, the less foaming we have. So that's how that's done. Viscosity improvers, as we talked in the previous lesson, are all about polymers which grow long and thin when they're cold and curl up when they're hot, giving us the ability to make a multi-grade oil. Now, I know this has been quick. What I want to tell you, though, is that we will go into much greater detail on each one of these types of additives as we begin in future videos to talk about how we formulate oil for a particular application, because then we need to connect those two. We want this in the application, and this is how the additive is going to do it, and I'll go into a deeper detail. But I needed to introduce to you today the additives, that you would understand that these are as important in this oil, if not more so important, than the actual base stock, because the additives will tailor the oil to the application. Okay? Now, again, I'm going to give you my advertisement here. I am Dan Watson. I am an AMSOIL jobber, and if you need anything to do with AMSOIL lubricants, or you just need questions answered about something that's bothering you and for your particular application, you can get in touch with me. All you have to do is go to thelubepage.com, contact me there. You can contact me at danwatson@thelubepage.com, or you can call me at 800-370-2986. So I'll see you in the next video, and we'll drill down a little bit deeper into these lubrication qualities and formulation of oil.